Hello everyone. Here in this video, we are going to discuss Runge-Kutta method of second order to solve ordinary differential equation, and later we'll check how to solve any kind of problem with this method. Okay. Now, Runge-Kutta method of second order is a numerical technique to solve ordinary differential equation of first order. Remember one thing, only first order ordinary differential equation can be solved by this Runge-Kutta second order method. Unlike the Runge-Kutta method of fourth order, what we have discussed in our previous videos. Okay, the link of those videos are given in the description box. If you are interested, please go and check. I think it will be helpful for you. Okay, now here the form will be given for this ordinary differential equation. Dy dx equals to fxy, where yx0 equals to y0. Okay, now yx0 equals to y0, that a value of x0 will be given even in the question, even y0 will also be given. Okay, and we have to find yn equals to yxn equals to how much. That value we have to find out using the Runge-Kutta method of second order. Okay, x1, x2, xn, these are the instances of x. Right now, the formula given here is n plus 1 equals to yn plus half of k1 plus k2, where k1 equals to hf of xn yn, k2 equals to h into f of xn plus h yn plus k1. See, k2's value will be derived from the value of h, xn, h, yn and k1. So without deriving the value of k1, k2 cannot be derived. Okay, now whenever we'll get all these values of k1 and k2 and then yn, it will be easier to find out yn plus 1, because for finding out yn plus 1 we require all these values of yn, k1 and k2. N can be any value from 0 to 0, 1, 2, 3, 4, etc. It depends on the question that how many times we have to take n, right? Now, remember this thing. This is very important. How many times we have to use the above formula depends on the value of h and xn. Now, what is h here? H is the step difference or step function or the increase between two consecutive instances of x, right? Now, if you can remember the previous video, or you can take reference from the previous video, that h is xi plus 1 minus xi. So xi plus 1 here equals to xi minus plus h. By this way, we can get x1. x1 will become x0 plus h. x2 is x1 plus h. Means h is an increase, okay, or the increment, right? From x0 to x1, x1 to x2, x2 to x3, and so on. So x1 will be x0 plus h. x2 is x1 plus h equals to x0 plus 2h. Why? Because if we derive the value of x1 here, x1 equals to x0 plus h plus h. So it is x1 x0 plus 2h. Similarly, x3 is equals to x2 plus h equals to x0 plus 3h. Okay, the value of h can be given in the question, or we have to derive this, okay, from the given values of x0 and y0, right? Now here, suppose we want to find y1, we have to put n equals to 0 in this equation. So if we put n equals to 0, it will become y1. It is y0 plus half of k1 k2, k1 plus k2. So it is y1 equals to y of x1. x1 is x0 plus h, so it will become x0 y0 plus half of k1 plus k2. Similarly, here k1 equals to h f of xn yn. h f of, putting the value of n equals to 0, f of x0 y0, and k2 equals to h f of x0 plus h y0 plus k1, x0 plus h y0 plus k1. Now if you need to put the value of n as 1, okay, then we have to go for step 2. It depends on the question that how many steps we have to go for. Okay, so putting n equals, if we have to go to step 2, then we have to put the value of n equals to 1. So y2 will become, here we have to put n equals to 1, so it will become 1 plus 1, that is y2, it is y1. Okay, so y2 equals to yx2, where x2 equals to x1 plus h, as I said h is the increment, equals to x0 plus 2h, equals to y1 plus half of k1 plus k2. And from this again, k1 and k2, by the formula we can derive the values very easily. h f of x1 y1 and k2 equals to h f x1 plus h y1 plus k1. Now consider a problem, then this method, to understand this method will be easier. Using Runge-Kutta order 2 method, find approximate value of y when x equals to 1.1, given dy dx equals to 3x plus y square, and y equals to 1.2, and y equals to 1.2 when x equals to 1. Okay, so y equals to 1.2, here it means y0 is 1.2, and what do you have to find? We have to find the value of y for x equals to 1.1, right? Now coming to the solution, this is given dy dx equals to 3x plus y square. So dy dx equals to f of xy equals to 3x plus y square, where x0 is given. Here y of 1.2 equals to y equals to 1.2. That means y0 equals to y of x0 equals to 1.2. And what is the value of x0? Here it is the value of x0. Y equals to 1.2 when x equals to 1. So y0 equals to y x0 equals to 1.2 and x0 equals to 1, it is given. See, just check this method. It will be in this form, dy dx equals to fxy, where y x0 equals to y0. Similarly here, y of y0 equals to 1.2. So if remember in question it may be given as this. So y equals to 1.2 when x equals to 1. Consider this as y0 and consider this as x0. So these values are given, right? x0, y0 and fxy. This equation is also given. We have to solve this differential equation, and when we have to find it, when x equals to 1.1, and then we have to find the value of y, right? So so we have to find f of 1.1 equals to fx1 equals to how much, right? Now see, in this question the value of h or the step difference is not given, so we have to calculate the value. Here the initial value of x is 1. We have to find out the value of y when x equals to 1.1. So h equals to x1 minus x0, that is 1 point minus 1 equals to 0.1, since x1 equals to x0 plus h. Okay, we have find it, we have got this from the previous section of this video. Okay, now so we'll get the value of h equals to 0.1. See, we can take, it is up to us what value we'll take for h. If h here we have taken h equals to 0.1. okay, that means only one step we have to follow, right? We can take the value of h as 0.1 by 2, then we have to go for 2 steps. Okay, now by Runge-Kutta method of second order, y1 equals to here in this section, put n equals to 0. So y1 equals to yn plus half of k1 plus k2, like this. Okay. So here y1 equals to y of x1 equals to y0 plus half of k1 plus k2. This is equation 1, where k1 equals to h f x0 y0, as in this formula xn yn. Putting n equals to 0, we'll get h f of x0 y0, right? So h into 3x0 plus y0 square, as it is given in this function, fxy equals to 3x plus y square. So it will be x0 y0 will become 3x0 plus y0 square. It is equals to 0.1. Putting the value of x0 and y0, we'll get this 3 into 1 and 1.2 whole square equals to 0. If we calculate, you will get 0.444, and that will be the value of k1. Similarly, we have to derive the value of k2. How? Putting n equals to 0, k2 will become hf xn, that means n equals to 0, so x0 plus h and y0 plus k1. So here k2 h f of x0 plus h, y0 plus k1. Now putting all these values, because all these values we have, x0, h and y0 are already given in the question, and k1 we have already calculated it, right? So putting all these values in this function, we'll get this, right? This is our whole x and this is our whole y, so it will become 3x and y square if we derive this function, right? So 3 into 1.1 plus this 1.644 whole square, like this, 3x plus y square, right? And it will become, after calculation, 0.60027, right? Now from equation 1, y1 equals to y0 plus half of k1 plus k2, well, we have already all these values, y0, k1 and k2. y0 is given, k1, k2 we have already calculated, right? So these two values for k1 and k2 respectively. So if we put all these values, we'll get this one. In this equation, we'll get the value after calculation, y 1.1 equals to 1.72213, right? And this will be our answer, because it was asked in the question that find the value of y when x equals to 1.1. Now this one is approximate value. If in the question it is given that find the value, approximate value for 3 decimal point or 4 decimal point, then the answer will be like that. Like for 3 decimal values, we'll get 1.722. For 4 decimal values, up to 4 decimal values, 1.7221. Okay, but if it is not given in the question that how much decimal places we'll go for, then it is up to you that how many values you will take. It may be 1.722, you can take also 1.72213, the whole thing. Okay, so this will be our answer, and hope you have understood the problem as well as the Runge-Kutta second order method for solving ordinary differential equation. I am putting this in a single screen so that it can be easier to take a screenshot. Okay. Okay, now if you have any query regarding this method or the problem, you can ask me in the comment section. I will try my level best to answer your queries. Thank you.